we're meeting for some projects that looks like have a lot in common. Making or wanting to make projectional editors for a new programming language of the future, which is functional and statically typed. So I'll describe the shared vision of the project as revealed by the features survey. We're making the programming language of the future, which is functional, statically typed, has type inference, but it doesn't work the way you're used to from Elm or Haskell. No traditional type errors. We have new UX solutions for that, like non-empty holes or fragments containing the type mismatch. We all like variant types and structural types, but at least for now, we're not considering dependent types. And unlike Haskell, we don't want pervasive lazy evaluation. The language should have syntax sugar. Code layout should be automatic. Programmers shouldn't deal with that. Unit tests should be a built-in feature of the environment. The editor should have a text-like UX. So we're not talking about visual programming languages, but also not text files. So a projectional editor that feels like text. What you type is what you see. And it should enable live programming. We would like it to work in the browser, and we believe that it will be a good fit for professional programmers. And now I'll go to the Lamdu specific presentation. And it's going to be about something that Lamdu does differently than most other projects. So I'm going to focus on two aspects here. One is our use of keyword arguments. So all the other projects are in positional arguments land, and we are in keyword arguments land. And positional arguments, I think in the time of languages like C, they wanted to save every keystroke and call functions like str, C, and P. You know, from C it came to C++, to Java, to JavaScript, and most languages use positional arguments. But I think that IDEs change the trade-offs. And if you don't have to type the labels and they help understand stuff, then it's good. So in this case, we see the filter function implemented in terms of fold, which has 4 arguments. So fold is an operator, and it has an argument on the left, an argument on the right, and 2 extra arguments, an accumulator initial value, and a tail, if you're familiar with fold-R and Haskell. And I think the labels help a bit readability. You don't need the labels to everything. This is similar to the Swift programming language. You know, when you have a verb, it works in a subject and an object, so not everything needs. And now I'll talk about syntax sugar. It's actually syntax sugar for passing a record of arguments. So there's 2 sides of it. One is there's a single argument, a record, and it accesses fields of the record, list field and a keep field. And this internal lambda, it gets a record. So this is syntax sugar. Just the parameter records. The other side of it is the application side. So this is just the fold function applied with a record of arguments. And the way syntax sugar works in Lamdu is opposite than the usual. There's no unsugaring phase before compilation. It is stored unsugared and displayed sugared. So I'll just show another sugar you may be familiar with from JavaScript. Field punts, if there's a field list with a value list, it can appear like this. By default, by the way, all the sugars are enabled. This is just for pedagogical reasons. But the way sugars work, if I edit it, it automatically goes out of the sugar form. So I don't have a lot of time, so I'll quickly show more sugars with an example. So I made I asked who wanted to test other projects in a Secret Santa, and I made a program to randomize Secret Santa. It's using the imperative side of Lamdu for randomness. So in this program, I'll make the window bigger so you see everything. So if statements, they are sugar for pattern matching on Booleans. Let expressions, right? If you see below, there was an if statement, but if I turn it, it becomes a pattern match. Let expressions are just beta radixes, just a lambda immediately applied with an argument. That becomes a let expression. Now, a lot of things people do like about positional arguments in Haskell or Elm is carrying or partial application. So we have a very useful sugar for that, which we call light lambda, similar to underscore syntax in Scala. Okay, I guess I'm out of time. So if you're curious, you can play with it yourself. Any questions?
Is there a commercial intent behind this, or is it an academic approach?
So Lamdu is, we're not academics. It's a passion project. We want to make programming great again. Programming, I do it. It's a huge pain. Many stuff in programming are, and it doesn't have to be. I think it could be delightful, and we're trying to realize that. It's very ambitious, but we've been working on it for a long time, and hopefully it will become useful.
So the sugars, can they be written as part of the program or like by the programmer? Or
so when I type an if, so if I type an if here, I type an if, a normal if, or otherwise, if I want to pattern match a Boolean, it will become an if. So wait, oh, never mind. I'm not sure if I answered the question, but you write it either in sugared form or not, and it becomes sugared.
Can you define, can a user of the language define new sugars?
So I imagine in the future, in the far future, you could define some sugars for user types. So for example, more for like the end user side of things, maybe you'll have like a video timeline nominal type that you could define a custom UI for, but that's far away in the future. Currently, it's all built in. Okay, so the next presentation in line is Dark.
So let me share screen and do a very quick demo of Dark. So this is the Dark editor. You see it's a cloud editor, and you can make HTTP endpoints very, very simply. So here's a quick hello world. And I will open that in a new tab, and there it is. So this URL exists in the in production in the cloud immediately, and people can go and hit that endpoint if they want. And one of the things that's most interesting about Dark, and this is the live programming feature, is that we have I call it trace-driven development. So this is the request that was just made by the browser. You can see the headers in particular, and we have a workflow that's built around making requests from your client, React or something like that, or mobile clients, to our backend, and then you start to build your code from that. So here's one I built earlier. Here's a 404 that I made against the backend, and when I click the plus, I get that, but I also get the body of the request, and so I can type request.body.email, and I see the actual email that the actual request that a user made. So I can start to build up in a sort of a way deferred computation. I use the traces to write the program, and then they create more traces. And so an application ends up being built very much in tandem between the back end and the front end, unlike how people do that today, which involves getting it into deployment or getting it into production via a pull request method and that sort of thing.
So I'll be talking about Hazel. So Hazel, you can go to hazel.org, and it's a web-based live functional programming environment. So what's different about Hazel? There's a few things. So one is that, like I said, this is an academic effort. So we have a bunch of research papers that have a bunch of theory in them about all the different aspects of the system. So for example, the live program, I think I brought this up. So, if you want to really understand how the live programming that I'm going to show you works, there's like a whole paper about that. So we really try to specify precisely what we're doing in this way. It's not necessarily the right thing for every project, but I think that is a unique kind of value that Hazel brings to the ecosystem. So you can go and click on Play with Hazel up here. I'll kind of jump into a demo that I like to give. So you might have seen this before, but I think it demonstrates a lot of things that we're doing. So we're going to implement quicksort functions. So if I start by defining quicksort as a list of int to list of int function, Then it's a function that takes some input. I'm using tab to move between these holes. The holes have unique numbers, which you'll see comes in a little bit handy. So I'm going to pattern match, return the base case, and then I'm going to start doing the kind of recursive case, which is the interesting one, right? And then quick sort algorithm, we sort of pick a pivot and we partition into kind of two lists, bigger and smaller. So I'll call partition. I have two holes I can move between. I can pull up this little type inspector to get information about the type of each hole. So here, the partition function needs a predicate that compares, let's say, to the pivot, which let's say is the head element. And then we're partitioning the tail. So now we have this hole here in the return position of this function. And so if I look at this example that I give myself to develop with, it just returns hole 33. And so, you know, a second kind of unique aspect of Hazel is that we have this kind of maximally live evaluator. So it's running code and it's actually not kind of stopping at holes. And you'll see that in a second, but it's actually computing these closures around holes. So if you look in the sidebar on the right, you'll see it's showing you the values of all of these variables that are in scope. So the tail was this, the head was this, and then these two partitions, smaller and bigger, were these. And if you kind of stare at these for a second, you'll see that I made a mistake. So, you know, I should have named this bigger and this smaller, or done the comparison in the other direction, because these numbers, these are not bigger, these are the bigger numbers. And so that's the proposition here, is that you want to be able to evaluate a line of code right after you write it. So I can go and fix that. And then the next step would be to recursively sort these things. So you can see, first of all, I have the correct values here now, and I need to recursively sort them. So I'll do that in a pair here. And now you'll see I have QS and QB, and these are recursive calls to this incomplete function. So they end up at hole 64 as well, but there are different instances of hole 64 because the runtime environment was different. So I can go and click on one of those and it changes the sidebar to show what the values were in that instance. And you can see that we've kind of recursed, broken down into these partitions, again, partitions working correctly, and so on. So that's the idea here, is you get feedback as you go along. Was that the out of time mark?
Yeah.
Okay, cool. I'll just hint that there's another thing that someone can ask me about in the Q&A or something, where we have non-symbolic editing as well. So, but I'll respect the timer and stop there.
So anyone has a question?
I have a question.
Yeah.
What is non-symbolic editing?
Is it cool if I give another quick demo of something?
Yeah, if it's short and answers the question,
Yeah,
sure.
yeah. So we have this livelets project. So the idea is basically, because it's a structure editor, you don't necessarily need to put in just kind of textual things. You can have things like sliders and color choosers and things like that. And what's kind of interesting about this example here is that the red, blue, and green components of this color are actually themselves Hazel expressions. So it's not that you go from code to GUI and then you're stuck in the GUI. You can actually go then back into code. And so this is actually doing some live computation here. So if I like change this slider, you're seeing this sort of trace of a semicircle in this color space here, because I've set up this symbolic relationship between R, G, and B. It's sort of more green than red and blue basically here. You can also kind of nest sliders compositionally into the alpha channel here, and that enables all sorts of other interesting things, like you can essentially implement a spreadsheet with proper formulas in Hazel and stuff like that. So this system is called live literals or livelets.
That's super cool. Thank you.
Yeah.
So David, you wanted to present tylr?
Yeah, so this is tylr, sort of an offshoot project from I was originally working on the Hazel project, and then we decided to kind of distill some of the editing ideas that we've been working on separately from the type and live evaluation concepts of Hazel. And so similarly to Frugal, we're also trying to go for a very text-like experience. Yeah, so let's just see, I'll just show you tylr in action here. So here's a little function where the idea is that it's going to return a circle object that goes through some two-dimensional point at center and goes through a point P. And so the first thing I might do is compute a radius. And so as soon as I type this let token, the matching tokens equals and in are put into what's called tylr's backpack here. And so the backpack, the basic idea of the backpack is that it represents your syntactic obligations that you are expected to meet before your program can be sort of considered complete again. And the backpack is automatically filled and sort of discharge, like the obligations are discharged as I type. So if I now go and compute a square root function, open a parentheses to start a function application, and I have the matching in parentheses here, and you'll see it continues to grow and shrink as I type. And let me just wrap that up. And so all of that was done with exactly the same keyboard input as you would use in a text editor. Now, I think there's been generally a lot of attention focused on text-like entry in structure editors. But another aspect we're really thinking about is how we can restructure existing code. And I think this was a focus shared by Frugal as well. And so I think one particular issue with structure editors is that often if you're editing the trees, when you're selecting things, you're kind of restricted to the complete trees. And so if you're projecting those trees to this kind of textual form, it can feel kind of jarring and restrictive to have to select, say, this entire let expression instead of, say, just selecting this let binding here. But here what's going on there? But anyway, in any case, here in tylr, like one of the ideas we're exploring is the idea of being able to disassemble or serialize structures into their projected components and be able to kind of operate on those partial structures, and then provide some sort of guidance and assistance to make sure that the way you put those partial structures back together, you still have a valid tree at the end. So let me just show an example. Let's say I want to extract these two let lines and this square root into a reusable distance calculation function. So I'll start just typing out here. And then I'm going to go over here, take these, put that there. Take this. Seems like some new bugs have appeared. And so, that's sort of what the experience looks like using tylr to perform that refactor. And so, again, we're trying to get as close to this kind of linear text-like editing experience as possible. And I'm happy to take any questions.
That's super cool. Is there a place we can try this out?
Yeah, actually, you can try this out now. So right now, the URL, so tylr.fun, this is an iteration of an earlier project that if you just go to tylr.fun, you'll see an older, much smaller version of this. But we have a bunch of different branches at different sub URLs. So you can actually, if you go to study 2022 June, we ran a user study recently on this. You can try it out yourself.
Very cool. Thank you.
I had a quick question.
Sorry, go ahead.
When you're typing, there's like a bracket that's either left facing or right facing. And I've been trying to decode when it's which. Is it just whenever you do a closing sort of element, it switches direction?
Okay, so if I were to delete this opening parentheses here, this closing paren needs a opening parens to complete it. And then correspondingly, if I delete this, this will be in the backpack with this highlighted.
David, I think he's talking about the tips on the caret.
Yeah, just the cursor itself.
See, I see. Yeah, so each of these structures are being each token kind of has angled tips that are either convex or concave, and they indicate whether or not they expect another argument on that side. So in this case, with the function application parentheses, it's concave on both sides because it's expecting the function on the left and then the first argument on the right. But if I were to delete this, there's a kind of remolding system here that remolds that to be convex here. So there is some internal parsing going on to change those shapes.
Thanks.
This is really beautiful in a very subtle way. And And I wonder kind of what affordances have you put into that sort of like design to make it so?
I mean, so I think like the particular like, yeah, subtle color scheme, we can thank Andrew for that. Andrew has been doing a lot of amazing sort of visual design aspects here, especially the backpack stuff. I'm really happy with how the sort of like stack based kind of, what's happening there? Let's say I do this, and you have this kind of like these bubbles going out. It's something that we've been iterating on for quite some time now, and we actually have some more thoughts moving forward about how, like right now, like the backpack is kind of tied with we're using the backpack as a clipboard where you can select things and put things in there. We're actually thinking now we should start to sort of divorce that from the backpack, and just have the backpack be sort of this derived completion menu for you. Yeah, sorry, that kind of went on a tangent there. I don't know if that answers your question.
Sure, thanks.
I'll just give a general note. Now it's the open-ended questions and answers / discussion panel time. Colin asked about what I said about how I think that while Frugal does let you have an environment that behaves just like text, it's something that I don't exactly want. And one thing I can say that working in C++ in Xcode, I already have an environment that doesn't behave like text. And sometimes it annoys me. But Apple made the decision to like complete stuff for you in ways that they found, I guess, to be more useful than being exactly a text editor. And I don't know if it's a real worry, but I think if it can be like too much of it unstructured, then there are a lot of services won't be available, and it would be like an inconsistent experience. I'll just show a really simple example in Lamdu. So I'm filtering the numbers from 1 to 1,000, then checking which ones divided by 3, and I get the sum of it. Like everything basically is valid and gets the services of running, and also I can, which I wouldn't have known how to do if it was free text, I can switch to like seeing it in Italian or Hebrew, which is right to left, or it doesn't matter. And like the key one, which is most important, I think, is the experience with type errors. So if I have the fact that the editor knows what was valid before and assigns the error here, in contrast to if I wrote text here and 5 here, the error would be assigned to here, is afforded by having everything that's possible valid all the time. And so the editor knows how to mark the new thing as invalid. And if too much is like in the free-form text, or there's too much invalid parts that live independently, I don't know if it would bring the same value. But I'm not sure, maybe it would.
I feel Paul raised an interesting question, though. I'm curious whether anybody has something to say about what Paul asked on the chat about live programming. And yeah, like if you have the full runtime history of your program, how do you portray that in a way that is meaningful to a user? Does anybody have thoughts on that?
Definitely. It's something that we have focused on. So I can show you, I guess, explain what goes on in Lamdu.
Please.
So normally, most of the time, maybe you're editing code, you want to see it succinctly without extra stuff, but maybe you want it to look like Java and see types everywhere. So you can enable it. Maybe it helps you. And we made up this notation that it goes under each sub-expression, but not totally under everything. So here, so it doesn't take more vertical space. So the modulus 3 or equals 0, the bool goes only under the right side, and some stuff are obvious. Numbers are numbers, so we don't show everything. When you turn on evaluation, we use the same places to show evaluation result under every sub-expression. I think it was Brett Victor made an article about how you don't want people to use hovers You want stuff to be less interactive because like browsing with your eyes is easier. And also I think compared to the sidebar in Hazel, you just see the result of each sub-expression under that sub-expression, and it replaces the need to extract it to a variable and do like a print statement debugging. And you can browse between different invocation scopes of the function. And to be honest, it's more of a proof of concept. Currently, we record the first 10 invocations. But in theory, I want us to be able that any function invocation within, you could go into that and view the evaluation of these inputs. And because it's a functional paradigm, I can show the value of a variable under that variable. Yeah, I think Jonathan has actually affected us to go the functional route for this. So yeah, num has one value. And I think this approach, I hope, makes functional programming accessible. And it uses functional programming to, yeah, you don't need print debugging, and you can see all the intermediate values. This is our design for it.
Just a quick question. I know I don't have my hand up, but I know you mentioned against interactivity, but I am curious if I wanted to find out what the second element was in one of those lists where it's being elided, is there a reason, or I guess you can do it that way, right? Interesting.
We can browse the scopes, and yeah, we can see what happened in the function filter, and it had this fold with this stuff, and
cool.
we will have more stuff. Like I think what you're alluding to, you can say it's kind of like breakpoints. Find also like being able to go, what was the calling scope for this, for the, yeah, we'll want a lot of all the stuff I'm missing from whatever I'm currently using in Python, we will want to have at some point.
So about the showing the results of expressions, I can show you in my project. And it's also an excuse for showing my project.
Yeah, let's do it.
Yeah, so here I have actually a Lisp style, and here I have more space at the bottom, so I can write a result of evaluation. And if I create a function, it's actually, oh yeah, and it's named randomly if I create more functions. Yeah, and for example, if here will be num, and it will be num plus 10, and I here execute. Oh, it's John. Okay. Yeah, great. And I will pass here 25. So yeah, it just shows the last one that was called.
Alexander, what if there is a nested expression, like if it was num times num plus 10?
Okay, let's try it. So you like num times
inside, just replace num with num times num.
Okay, I cannot do this. I can actually, so I will need to create it out of the, so it will be 10, and this will be num times num, and run again. So it will be John, and 25 one more time. Yeah, here it is.
Okay.
So, and yeah.
Okay.
So I would
say?
Thinking primarily in terms of debugging, or even just reading code for the first time, like as opposed to jumping to a definition, just seeing like what it would look like unrolled in that context.
I can answer your question. I have a canvas, so I can open the definitional function next to its call, and it looks like this. So one more sharing. For example, if I actually click here and click open definition, it just brings the code here. Or if I click like on the latest one, it just brings here. And for same for example, plus, and it just arranges here. Or I can actually open more and see more.
Yeah, I mean, I like that a lot, how you're building up the tree structure. Everything is in its place as opposed to just dissociated panels of code.
Yeah, and also if you open, I can show borders of each object, and then it will be like this, so it will push it away. In comparison to blueprints in Unreal Engine, you have to manually, and Blender, you have to manually put nodes in a space. I don't like this. I like automatic layout.
There's some of Rolly's stuff you pulled up here.
This is Jonathan Edwards, but maybe
Oh,
Rolly
this is Subtech. Okay, yeah, he's got a
similar?
similar
Yep,
kind of
yep.
interaction, but yeah.
It's similar to what Alexander showed, so I wanted to pull it here. Jonathan was here before he left, but this is early subtext stuff. I think he pivoted from this design, but it's similar, and it has this nice like thing that shows what opens from what.